Hello, how are you? My name is Abdullah Al-Dimashki, and I'm a software engineer student. Today, we will talk about IP address validation in the IPv4 and IPv6 era. Introduction to the research paper. The modern internet depends on accurate validation of addresses to maintain security, reliability, and efficient network operations. IPv4, created decades ago, has long supported global connectivity but now faces exhaustion due to the rapid growth of online devices. This shortage led to the introduction of IPv6, which offers a vastly larger address space and enhanced capabilities. The, the third point is in this introduction, the existence of IPv4 and IPv6, which present new challenges for researchers, network engineers, and security professionals who must validate two different address structures with distinct rules and constraints. Proper validation is vital for network management, threat detection, geolocation accuracy, routing, decision, and ensuring compliance with regional address allocation policies. Third thing, uh, this study compares IPv4 and IPv6 validation techniques, explores evolving methods, and highlights best practices for maintaining secure and stable connectivity in dual stack environment. It's aimed to support a smooth transition forward IPv6 while uh, safeguarding the integrity of today's internet infrastructure. The literal overview, there's five things we will talk about. The first point is the literal overview. Sorry. First point is early techniques. Reverse DNA and whose uh, queries useful but limited in precision and real-time capability. Second point, geolocational databases. Use of commercial datasets like MaxMind GeoIP for mapping IP to regions and evaluation studies of their accuracy. Third point, machine learning methods. Application of classifier like SVM, decision tree, and deep models such as CNNs, RNNs for richer feature extraction, useful for tasks like distinguishing IPv4 and IPv6, inferring anonymity or geolocational pattern. The fourth point, behavior and anomaly detection, modeling IP behaviors over time to flag suspicious activity for intrusion detection. Last point, emerging challenges, real-time detection requirements, privacy trad office, anonymization, anonymization, complicating attribution, and IPv6 specific issues that require adapted detection logic. The review concludes by underscoring the need for methods that balance precision, privacy, and real-time operation. Methodology. This study developed a C++ method to detect IPv4 and IPv6 addresses within textual data. The process began with collecting and preparing the data by cleaning unwanted characters, removing HTML elements, and organizing the text for processing a C++ program tokenized the text into individual words, and regular expression from the regex library were used to identify IP address pattern. Detected addresses were stored in data structures such as vectors or lists for easier analysis. The method was tested on multiple data sources to ensure accuracy, reliability, and efficiency. Performance matrices including precision, recall, accuracy, and FI score were evaluated, and the algorithm was optimized for memory usage and processing speed. Last thing, the study presented the identified IP addresses along with their text context, discussed limitations, suggested direction for future research, and provided full citations for all references and tool use. The result and analysis of a research paper. Regex rule accurately distinguish valid from invalid IP format using clear examples such as valid IPv4 address, which is 172.26 254 one as example, versus an invalid one with a leading zero, which is the other IP address, and a valid IP6, which is the one that begin with 200, versus a malformed version containing incorrect hexadecimal components. The paper includes implementation artifact figures showing accepted and rejected matches along with C++ validation code supporting reproducibility for practitioners. Also, second result, during evaluation, the author states that they measured standard matrices such as precision, recall, accuracy, and FI score, reporting that the method performed reliably for their datasets. Their decision focuses more on syntactic correctness and acceptable runtime behavior than on quantitative quantitative depth. Last thing, a critical limitation is the lack of detailed numerical results. The paper doesn't provide dataset sizes per class, precision or recall, or comprehensive runtime benchmark. This limits the generalizability of the finding, particularly for large-scale or adversarial text environment. In conclusion, the transition from IPv4 to IPv6 is essential for supporting the future growth of the Internet. IPv6 solves IPv4 address limitation and offers improved security, scalability, and performance. The C++ implementation in this study showed that IPv6 can operate as efficiently as IPv4, reinforcing its suitability for modern network. Although the migration process remains challenging, the long-term benefits of IPv6 far outweigh the difficulties, ensuring a smooth transition and continued research will be vital for stable and future-ready future-ready internet environment. These are the references used for the research. Thanks for watching.